Permutations and combinations. Question number one. How many words can be formed from the word Mississippi in which no two S come together? Let's see the solution. In the word Mississippi, letter I, one, two, three, four. So I occurs four times and S occurs four times and P occurs twice. P occurs two times. Now, condition is no two S come together. So let's arrange it, leaving the space for S. Now, here there are eight spaces. 1, 2, 3, 4, 5, 6, 7, 8, where S can be accommodated. And there are 4S. So these 4S can be arranged in A to C, four ways. 8 places are there and 4 S's are there. And now remaining 7 letters can be arranged in factorial 7 ways. Since there is a repetition of I 4 times, so divided by factorial 4 times P is also repeated twice, so factorial. This can be simplified. Now let's see next question. Question number 2 says, prove that the value of 50C4 plus sigma r equal to 1 up to 6, 56 minus r C3 is equal to 56C4. So let's see the solution. 50C4 plus, here we can put the value of r. So we will get 55C3 plus 54 C3 plus 53 C3 plus 52 C3 plus 51 C3 plus 50 C3. Now we can start grouping. The formula is, we know that NCR plus NCR minus 1 gives N plus 1 CR. So same formula we can apply. So we can start from here, 50C4 and 50C3. So these two will give 51C4. Now 51, and then other things we can write. So this we can write like this, 51C3, then rest thing 52C3 plus 53C3 plus 54C3 plus 55C3. Now again these two will give 52 by same formula, 52C4 and plus 52C3 plus 53C3 plus 54C3 plus 55C3. Again, these two will give 53C4 plus 53C3 plus 54C3 plus 55C3. These two will give 54C4. So 54C4 plus this thing, 54C3 plus 55C3. Now these two will give 55C4, and then 55C4 plus 55C3 will give 56C4, which is our required answer. Now, let's see question number 3. So, here we have to prove that NCR plus 1 plus NCR minus 1 plus 2 NCR equal to N plus 2 CR plus 1. So, consider LHS. So, it will become NCR plus 1 plus NCR minus 1. We can write it twice, NCR plus NCR. And now we can group these two. So NCR plus 1 plus NCR plus NCR plus NCR minus 1. Now, as per formula, NCR plus NCR minus 1 gives N plus 1 CR. Here, this will become N plus 1 CR plus 1. And by same formula, this will become N plus 1 CR. And again, applying formula, this will become N plus 2 CR plus 1, which is our result. Now, consider next question. In how many ways can 8 identical balls be divided into 3 different boxes so that no box is empty? So, solution. Total number of ways of dividing n identical balls in r distinct boxes. N balls in r boxes when no box is empty is given by the formula n minus 1 c r minus 1. Here, clearly n equal to 8 and r equal to 3. So we put this value. So number of ways equal to 8 minus 1c, 3 minus 1, that is 7c2. So it will become 7 into 6 divided by 2, that is 21. Let's see next question. In how many ways can the letters of word garden be arranged so that the vowels occur in alphabetical order? So there are 6 characters in garden. Okay, 1, 2, 3, 4, 5, 6. So total number of ways will be factorial 6. Now these words will occur in the order either AE or EA. So they are equally likely. So we divide the number of ways by factorial 2. So possible number of ways when vowels come in alphabetical order will be factorial 6 divided by factorial 2, which can be evaluated. Now, let's see next question. What are the total number of ways in which 6 plus signs and 4 minus signs be arranged in a line so that no two minus signs occur together? So let's write plus sign, plus, 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 plus. There are 6 plus sign. And now let's see number of gaps for minus sign. These are the gaps where minus sign can be occupied. So there are 7 places. 1, 2, 3, 4, 5, 6, 7 places where 4 minus signs can be accommodated. So we can say that number of ways equal to 7C4. So this will be equal to factorial 7 divided by factorial 7 minus 4 and factorial 4, which can be easily evaluated, and that will give 35, which is our answer. Thank you.